All right, friends, one more try. I hope the problem is fixed now. If you can quickly check and let me know if the audio quality is fine, we can get started. I'm really sorry and sincere apologies for this disturbance in the audio that we have come across today. I just hope that it's working fine now so that we can get started with our session on data analysis and interpretation for the IBPS PO main exam. Boys and girls, I'm waiting for your response on the audio quality now. This is just one more try from our end. I hope it's working fine now. All right, I see a lot of confirmations here. A lot of students have responded that it's fine. So I guess we are good to start. Yes? Okay. Thank you so much for that confirmation. Okay, so thank you all for bearing with us, and sorry once again for this inconvenience. Let's quickly get started with a session on data analysis and interpretation for the upcoming IBPS PO main examination. Now, like I've mentioned, this is a series of sessions that we're going to do called the refresher series, where we'll try and refresh all your concepts through various questions that we solve here. And these questions will be, or these questions have been chosen from the mock test conducted by GradeUp, right? Considered to be the toughest of the questions based on how students have performed on these questions there. All right, so I've got a set of or a mix of very interesting questions for the session today. You know that the focus in main examination, whether it is an IBPS PO main exam or an SBI PO main exam, is mostly on data analysis and interpretation, like the subject is called, right? So there will be questions which are all based on data. A lot of data is given to you, either in terms of a table or a bar graph or a pie chart or a line graph or some mixed graph, or data is given just in terms of a paragraph, right? You got to analyze the data and then answer the questions, right? You analyze the data, interpret the data, and then try and answer the given questions, right? It can also include questions on set theory, because that's again one form of data-based question, right? Data provided to you in terms of sets, analyze that and then answer the questions. Or there can be questions on data interpretation, data sufficiency, where you have a question statement followed by 3 statements, and your job is to identify if the given statements are sufficient enough to arrive at the answer for the given questions, right? Likewise, in the recent exams, last year we had seen that there were questions where a lot of data was given based on which 3 quantities were to be found to be arrived at, and then we got to do a comparison between the quantities, right? If you had gone through the previous year paper or last year's IBPS PO exam or SBI PO main exam, there are 3 statements. Each statement is about a quantity, quantity 1, quantity 2, quantity 3. Now each of these quantities requires a question to be solved. For you to arrive at the quantity, the value there, you need to solve a particular question, right? And then compare between the 3 values and get the relationship. Is Q1 greater than Q2 greater than Q3, or Q1 less than Q2 less than Q3, and so on. Okay, so that again is about data. So basically the point that I'm trying to make is every question that you're going to face in your IBPS PO main exam will be on data, and data is all about numbers. So the one thing that you have to very sincerely work on in the remaining 2-3 weeks that you have is your numerical skills. I hope all of you have been preparing on that for a long time now, right? The fact that you have cleared preliminary examination shows that you are good in numbers. However, you should continue with your practice on numbers and see to it that you can do these calculations really quick without putting pen on paper. Okay, so keeping that in mind, let me present the questions. Remember, these are time consuming questions. I am choosing some very complex questions, complex not in terms of the difficulty level, but in terms of the time required to arrive at the answer, right? All these questions will be lengthy, but there is no choice. Either you solve or you skip. But if you are good in numbers, you can solve and get the answers really quick. So let me present the first set of questions to you all, where we are going to discuss about the comparison between 2 or 3 quantities. Okay, so the first question from your session on data analysis and interpretation is on your screens now. Now read the directions. What does it say? It says Devyanshu bought 12 liters of pure milk and added 6 liters of water to it. He sold 3 liters of the mixture formed. Now there are 3 quantities. You can see quantity 1, quantity 2 and quantity 3. What is quantity 1 all about? He says the percentage of milk in the final mixture if he sold another 3 liters and again added 2 liters of water to the remaining quantity. Quantity 2, he says the percentage of milk in the final mixture if he sold 24% of the mixture and then added 1.7 liters of water into it. And quantity 3, he says, is the percentage of milk in the final mixture if he sold 1/4 liters of 1/4 liters and added 2.75 liters of another mixture of milk and water in the ratio of 4:7. Right? So you got to find out what is quantity 1, 2 and 3 in terms of magnitude, and then do the comparison to arrive at the answer. Your answer can be any one of these 5 options: A, B, C, D or E. So I'll leave you with this for a couple of minutes. All of you can try it out. All these quantities are, independent questions of allegations and mixtures. You got to be strong in allegations and mixtures, or you should know the concepts of allegations and mixtures to solve these questions. So try to find out all the 3 values, 1, 2 and 3, and then do the comparison. There's no shortcut. Either you solve it completely, it may take up to 1.5 minutes, or you just skip and go to the next one. Your clock starts now. Let's quickly solve a few questions on this comparison of quantities, and then we'll move on to some interesting missing data interpretation type of questions. Okay. Quick. And just one important point that I would like to highlight here: this is not 1/4 liters, but it is 1/4. Right? Quantity 3, the percentage of milk in the final mixture if he sold 1/4 and later added 2.75 liters of another mixture of milk and water in the ratio of 4:7. It's not 1/4 liters, it is 1/4. All right. Let's see how many of you are able to crack this one. Option A is what I see that some of you have marked as the answer. Waiting for more responses. Option C, option D, option A. There are multiple answers that have come in. Kishore has marked option B, and so has Shankar Rao. Last 30 seconds, and then we will take this up. There's no shortcut. You have to find out all the 3 values and then arrive at the comparison. Or maybe once you have arrived at quantity 1 and quantity 2, you just see if you can eliminate a few options there, right? All right, time is up, so let's discuss the solution now. Here we go. So the question here says that Divyanshu bought 12 liters of pure milk and added 6 liters of water to it. He sold 3 liters of the mixture formed, right? So basically he has taken 12 liters of milk, 6 liters of water. He'll get a mixture, right? What will that mixture be? That mixture will have, the quantity will be what? 18 liters, 12 liters plus 6 liters, 18 liters. 18 liters of the mixture, right? Which consists milk and water. In what ratio milk is to water? See, 12 is to 6. 12 is to 6 is nothing but 2 is to 1. So this mixture has got, quantity of 18 liters, and milk and water have been mixed in the ratio of 2:1, right? Milk and water have been mixed in the ratio of 2:1. Now what did he do? He has sold 3 liters of the mixture formed. He sold 3 liters of the mixture formed. So out of 18 liters, 3 liters have been sold. What is remaining? 15 liters is remaining, right? 15 liters is remaining. Now we have been given 3 statements. Each statement refers to a particular quantity. Now quantity 1, what is quantity 1? He says quantity 1 is the percentage of milk in the final mixture if he sold another 3 liters and again added 2 liters of water to the remaining quantity. So try to understand, guys, that out of this 18 liters, 3 liters has been sold. 3 liters is sold. So what is remaining? Remaining is only 15 liters. Let's not write all the steps. Sold 3 liters, so remaining is 18 minus 3, 15. Out of 18, 3 has been sold, remaining is 15 liters. What will be the ratio of milk and water in this 15 liters? It will still remain 2:1. See, the ratio will not change. The concentration of milk and water will not change. Only the quantity will change. So out of 18, he has sold 3. So what he's left out with is 15 liters now. So he has now got 15 liters of a mixture where the ratio is 2:1. Can you tell me how much is milk and how much is water here? See, if you divide 15 in the ratio of 2:1, you'll get 10 liters and 5 liters. So I can say the quantity of milk is 10 liters and that of water is 5 liters. 10 and 5, right? So 10:5 is 2:1 and 10 plus 5 is 15. That's the idea. So this is what we know in the very first step. We have not gone to any of the quantities yet, right? See, explanation may take a little longer, but you got to understand that this analysis will not take more than 10 seconds for you. 18 liters, of which 3 is sold, 15 is remaining, the ratio is 2:1. Now look at quantity 1. What is quantity 1? Do the calculation. The percentage of milk in the final mixture, if he sold another 3 liters. See, he has sold another 3 liters. If he has sold another 3 liters, what is remaining? Out of 15, only 12 is remaining, right? So remaining is what? 15 minus 3. You can directly write 12, right? Now if you divide milk and water in the ratio of 2:1, 8 liters of milk and 4 liters of water. You're getting it? Total quantity is 12 liters, dividing the ratio of 2:1. So 8:4 is 2:1 and 8 plus 4 is 12. And after selling 3 liters, we are left with 15 liters. We are left with 12 liters, of which this is milk and this is water. And he again added 2 liters of water to the remaining mixture. In the remaining quantity, he has added 2 liters of water. So plus 2 liters of water. 2 more water has been added. So we had 8 liters of milk and 4 liters of water. He has added 2 more liters of water. So now what is he asking us to find out? The percentage of milk. Quantity 1 is nothing but the percentage of milk. Can you tell me what is the percentage of milk? Percentage of milk in this one. How much is milk? 8. Out of total, 8 plus 6, 14. Remember, total quantity is 8 plus 4 plus 2. Total milk is 8, total water is 4 plus 2. So 8 plus 4 plus 2 into 100. So percentage is the quantity of milk divided by total quantity into 100. So 8 by 14 into 100. 8 by 14. 8 by 14 is nothing but 4 by 7. 8 by 14 is 4 by 7. What is 4 by 7? Again, this requires your numerical skills, right? You know that 1 by 7, 1 upon 7 is 14.28 percentage. Or to be precise, 14.2857 percentage. And you are supposed to remember all these fractions by heart. Learn all these fractions by heart. It will be useful in such cases, right? 1 by 7, 2 by 7, 3 by 7 and so on. 4 by 7, 5 by 7 and so on. So 4 by 7 is going to be 1, 2, 4, 5. 4 by 7 is going to be 57.1428 percentage. There is a technique of how you find 4 by 7 in terms of percentage. How do you convert 4 by 7 into percentage? We have discussed this technique in our videos, TalentSprint's videos. I would suggest you all to go through it to be able to do this calculation, without putting pen on paper. So basically, the value of quantity 1 is how much? 57.14 percentage, approximately 57.14 percentage. The percentage of milk is 57.14. Likewise, find out quantity 2, quantity 3 and so on, right? Find out quantity 2. What is quantity 2? Understand, according to quantity 2, see, again he is talking about the percentage of milk in the final mixture. If he sold, instead of 3 liters, he is given 24 liters of the mixture, 24% of the mixture. 24% of the mixture is sold. See, 24% is equal to what? 24% of what is sold? 24% of this 15 liters. This 3 liters was initially sold. After that, 24% of 15 liters has been sold. 24% of 15. How much is 24% of 15? Anyone? 24% of 15 is going to be 3.6 liters. Right? 20% of 15 is 3. 4% of 15 is 0.6. So 3.6 liters. Which means he has sold 3.6 liters. Initially he sold 3 liters. Now he has sold 24%, which is 3.6 liters. And then he has added 1.7 liters of water to it. Earlier he added 2 liters. He added 2 liters of water. Now he has added 1.7 liters. So everything remains the same. Only the values would change. What is remaining now? 15 minus, instead of 3 you have to take 3.6. Earlier he sold 3, now he sold 3.6. 15 minus 3.6 is what? 11.4, right? 11.4 liters. 11.4. Remember, 11.4 liters will have how much milk and how much water? It should be divided in the ratio of 2:1. The ratio of milk to water will remain the same, 2:1. This will not change. Yes or no? It is the same initial mixture. Only the quantity has reduced. Concentration will not change. So you have to divide 11.4 in the ratio of 2:1. Right? So how much will be milk here? Divide 11.4 in the ratio of 2:1. Divide into 3 parts basically. 114 divided by 3. That's the idea. Divide into 3 parts. 2 parts will go for milk and 1 part will go for water. You're able to follow? 11.4 I'm doing this. It should be divided in the ratio of 2:1. So basically total 3 parts. Consider this to be 114 for the sake of simplicity. So 114 by 3 parts. How much will that be? 38 each. 30 into 3 is 90. 8 into 3 is 24. 38. Now out of 38, so each part is 3.8 basically. Each part is 3.8. I mean, if you put the decimal back. So 2 parts will be 3.8 into 2, 7.6. And 1 part will be 3.8 into 1, 3.8. You can check 7.6 plus 3.8. 10 plus 1.4, 11.4. You're getting it? See, that's all you have to be really good at, right? I mean, you have to be very quick in numbers. So I can say that out of this 11.4, 7.6 is milk. And remaining 3.8 is water. Now, understand, after selling 24% of the mixture, we were left with 11.4, in which 7.6 is milk and 3.8 is water. And then he has added 1.7 liters of water, plus 1.7. Like earlier 2 liters, now 1.7 liters of water. Now you do the calculation again. What calculation has to be done? The percentage of milk. He's asking us to find out the percentage of milk. So what is the percentage of milk? What's the percentage of milk in these two? How much is milk? Milk is 7.6. Divided by 7.6 plus 3.8 plus 1.7. Or basically you can say 11.4 plus 1.7. Because 7.6 plus 3.8 is 11.4. Right? Plus 1.7. Either ways you get the same value. Right? 11.4 plus 1.7 into 100. So basically this is 7.6 by 13.1. Or 76 by 131 into 100. Now this calculation needs to be done. You have to do this calculation to find out the relationship between Q1 and Q2. Now see, there is one advantage of comparing Q1 and Q2. Instead of finding out Q3 first, instead of finding out Q3, if you look at the options, option A says Q1 is less than Q2. Option B says Q1 is more than Q2. Option C says Q1 is less than Q2. And option D says Q1 is more than Q2. Option E says Q1 equals to Q2. I mean, if I just compare Q1 and Q2, I am sure at least 3 options will get eliminated. Suppose you are solving this question in the last 1 minute and time is about to get over. No point in finding out Q3. Compare Q1 and Q2. Definitely 2 or 3 options will get eliminated. Yes or no? Either Q1 will be less than Q2, or Q1 will be more than Q2, or Q1 will be equal to Q2. There is no other choice. So if you just compare Q1 and Q2, you will be able to, find out the result. Yeah. So compare that. How do you compare? You've got 57.14%. Find out what percentage will this be. Will this be more than 57 or less than 57? All about your numerical skills. There is no concept involved here. It's all about your calculation ability. So 76 by 131. It is like 76 by 131. Try to do the calculation. See, for 131, it's approximately 130, let's say. It's like 76 by 130. You getting it? I am taking it as 76 by 130. Right? Now, if you look at 76 by 130, for 130, 10% is 13. For 130, 10% is 13. 50% will be 65. 60% will be 78. This is close to 78, right? But less than 78. So less than 60%. How much less? If you really see, it is like 65 plus 11. 65 plus 11. 9% here is going to be 117. 8% is going to be 104, and 6% is going to be 91. So I think this will be more than 57%. This will be around 58%. This will be around 58%. So you got to do that calculation. I mean, whatever I'm doing mentally, whatever voice you are hearing now, you have to run through the same thing in your mind. Or there is another way of comparison, right? If you don't want to get into all this mess, there's one more way of comparing it. See, forget about the percentage here. What is Q1? Q1 is equal to 4 by 7. Q1 is equal to 4 by 7, right? Q1 is equal to 4 by 7. What is Q2? Q2, what we have got? 76 by 131. 76 by 131. Now you know how to compare two fractions. This again has been discussed in TalentSprint videos. Let me tell you how to compare two fractions. Two fractions of this type, right? Where we have no clue about what the value could be. See, one simple way of comparing the fractions is to make either the denominators equal or the numerators equal. Either make both the denominators equal or both the numerators equal. Now I think 4 into 19 is 76, right? So what we can do is we can multiply quantity 1 by 19 in both numerator and denominator. Yes or no? What I'll do is, let's multiply quantity 1 by 19 in both numerator and denominator. So what happens? We'll get 4 into 19 divided by 7 into 19. Why are we multiplying by 19? Because once I multiply 4 with 19, I'll get 76 in the numerator, which is equal to the earlier other numerator, right? What is 7 into 19? 7 into 19, it is 133. Now you compare. Quantity 1 is 76 by 133. Quantity 2 is 76 by 131. Which should be more? Quantity 2 should be more. Because in quantity 1, both the quantities numerators are equal. So forget about numerators. Just look at the denominators. Quantity 1 is 133 in the denominator. Quantity 2 has got 131 in the denominator. Denominator is less implies value is more. You're getting it? Denominator is less. See, this is how you compare. Very quickly you compare. Either make both the numerators equal or make both the denominators equal. There's one more way of doing it. Cross multiplication. Cross multiplication also is possible, but now we don't have to do. We can come to a conclusion that Q1 is going to be less than Q2. Q1 is less than Q2 because in Q1 the denominator is more than the denominator of Q2. So quantity 1 should be less than quantity 2. Immediately I know that option B, option D and option E are wrong. Because here it says 1 greater than 2, 1 greater than 2, and here it says 1 equals to 2, which is not the case. 1 is less than 2. So either option A or option C should be the answer. Now if you don't wish to spend any more time, make a guess. Either mark A or C. Either mark A or C. And it is more likely that the answer should be option A. Why? If you see option C, in option C we cannot compare Q1 and Q3. This is coded inequalities. I mean, this is a concept of coded inequalities. We cannot compare Q1 and Q3 here. Why is it so? Because it says Q1 is less than Q2 and Q3 is also less than Q2. In such a case, 1 and 3 cannot be compared. But we need a proper comparison. So in all likeliness, option A has to be the answer. Right? 3 options are eliminated. I'll make a better choice between A and C, and I think A should be the answer. However, you would say, no, I want to do a complete calculation. I don't want to take any chance. So find out quantity 3. Right? So let's work on quantity 3 very quickly. There is no shortcut, guys. Let me tell you, if you are wondering that what is this? Is this what we have to do in the exam? Yes, this is what you have to do in the exam. Either solve it or just go to the next one. But there is no shortcut. The only shortcut is you cut down the number of steps that you write on paper. Right? The only shortcut is you do your calculations very quickly. Right? Now let us work on quantity 3 very quickly. Quantity 3, Q3. Okay, what does it say in Q3? The percentage of milk in the final mixture, if he sold 1/4. Now he has sold 1/4. 1/4 of what? 15 liters. 1/4 of 15 has been sold. How much is 1/4 of 15? 3.75 liters. So if 3.75 is sold, what is remaining? So when it comes to quantity 3, remaining is how much? Out of 15, 3.75 is sold. Or you can say 3/4 of 15. Either take 15 minus 3.75 or directly take 3/4 of 15. So 15 minus 3.75 is 11.25. This is remaining. Now divide 11.25 in the ratio of milk and water. 2:1. I think we'll get 7.5 and 3.75. This is 7.5 and this is 3.75. 7.5 and 3.75 adds to 11.25 and the ratio is 2:1. You're getting it? Like whatever we have done in 1 and 2, similar process here. Now what happens here? He sold 1/4, so remaining is 3/4. In that remaining 3/4, we have found how much is milk and how much is water. Now added 2.75 liters of another mixture of milk and water. Now this is interesting. He has added another mixture of milk and water. Earlier he had added only water, but this time he has added milk and water. Right? This time he has added milk and water both. In what ratio? 4:7 ratio. Right? And how much quantity? 2.75. 2.75. Now what is he asking us to find out? Percentage of milk. Percentage of milk. So find out how much is the percentage of milk. See, look at this. Percentage of milk is going to be 7.5 here. This time there will be some additional milk from second item also. Earlier the second item was only water. You see, pure water. Here also pure water. But this time it's a mixture. How much of mixture? 2.75 liters of mixture, in which milk is 4 parts, water is 7 parts. So the additional milk that we have got is 4 out of 11 multiplied by 2.75. You understand? I think I short on space there. Let me just do one thing. I need some more space here. I'll write this step again, right? See, this time we have got milk from two different sources. Milk from initial mixture we had and milk from the new mixture, right? So Q3 is going to be what? Milk from the initial mixture is 7.5 as it is, plus milk from the new mixture. 4 parts out of total 11 parts. 4 out of 11 multiplied by this 2.75. 2.75 divided by, see, percentage of milk, right? So percentage of milk is total milk divided by total quantity. What's the total quantity? See, 11.25 is this quantity and 2.75 is this quantity. 11.25 plus 2.75. 2.75. Simplify this now. See, 4 into 2.75 is 11. 11 by 11 is 1. So basically the numerator is 7.5 plus 1, 8.5. The denominator is how much? 13 plus 1, 14. 8.5 by 14. 8.5 by 14. 8.5 by 14. Yeah. So quantity 3 is equal to 8.5 divided by 14 into 100. That's the percentage. Now this percentage calculation you do and then compare. You're getting it? 8.5 by 14. However, if I compare with the first value, see, first value was 4 by 7, which is nothing but 8 by 14. Q1 is equal to 4 by 7, which is equivalent to 8 by 14. Here Q3 is equal to 8.5 by 14. So definitely Q3 is more than Q1. Q3 is more than Q1. But is it more than Q2 or not is the question. I think the fact that Q3 is more than Q1 tells us that the answer is option A. Because there is a definite comparison between Q3 and Q1, right? Q1 is equal to 8 by 14. Q3 is equal to 8.5 by 14. So obviously Q3 is more than Q1. If I look at option C, can we compare Q1 and Q3? No, there is no comparison between Q1 and Q3. Yes or no? Q1 is less than Q2. Q3 is also less than Q2. That does not give us any comparison between 1 and 3. So option C also gets eliminated. And the best choice is option 1. The best choice is option 1. You're getting it? So I think the concept is the same. Allegations and mixtures. You should know how these things work. The only trouble here would be with numbers. And that's why I've been telling you that, guys, you have to practice on numbers. That's about it. I mean, it's all about how quickly do you deal with these numbers. And yes, I agree that this is a lengthy one. I mean, 3 quantities, each one involves a lot of calculation. So, you know, it would need at least 1.5 minutes of your time, 90 seconds to 120 seconds of your time to get the answer. But if you can eliminate the answer smartly, like what we had done initially, maybe you save some of your precious time. So option A is the final answer. Learn how to compare fractions. I think that's important. Like how we had compared Q1 and Q2, right? So the moral of the story is you should know how to compare the fractions quickly. See, one best way to compare fractions is to cross multiply. Cross multiplication is one technique which can, help you compare the fractions very quickly. That technique has been discussed in our videos. I will not discuss it again here. You can watch TalentSprint videos on percentages to know how to compare fractions and number systems to know how to compare fractions. Okay, let me present the next question to you all. Similar concept, 2 or 3 quantities given to us. We got to compare and find out the answer. Here we go. So here's the next question. Try this now. So this time only 2 quantities, quantity 1 and quantity 2. And this is on time and distance. The previous question was on allegations and mixtures. Now the question is on time and distance. It will carry 1 mark. Remember, weightage is only 1 mark. You will get 1 mark if you compare it properly. So is 1 more than or equal to 2? Is 1 less than 2? 1 greater than 2? Or 1 less than or equal to 2? Or no relationship? So solve this. Looks like a simple one, right? Time and distance. Quick. Rahul Kumar has asked me a question. Should we do or skip such problems in the real examination? Well, Rahul, it depends on how complex are the other questions. I would say you should have skipped the previous one and tried this one. If there are 2-3 such questions, solve the easier ones first. Always solve the easier ones first. And you can't really skip many such questions in the exam because every question would be time consuming when it comes to main exam. From the last 2 years of experience, it's very clear that every question is going to take a lot of time. So you better solve all that you can, do. Got it? All right, time is up. I don't think we should be spending more than this much of time in the exam, right? So let's find out the answer now. Look at this. This time he says, again, find out the appropriate relationship for quantity 1 and quantity 2 in the following question. Now, what is quantity 1? Quantity 1 is time in which the policeman will catch the thief if the policeman is lagging behind 800 meters and is moving at 56 kilometers per hour while the thief is at the speed of 48 kilometers per hour. So this is a typical relative speed question, right? Very interesting one where a policeman has to catch a thief. I'm sure if you have learned time and distance, or if you have gone through our videos on time and distance, you would know this concept very clearly and very thoroughly, right? Very interesting concept. A policeman has to catch a thief. Now, without drawing any diagram and all that as to what happens, you just need to understand that the policeman is running at 56 kilometers per hour, thief is running at 48 kilometers per hour. The distance between them is 800 meters. So for the policeman to catch the thief, he should cover this distance, 800 meters. How much time is required? So I think quantity 1 is nothing but time. What is time? Time is equal to distance by speed. Now speed in this case is the relative speed, right? What's the distance? 800 meters. Remember, distance to be covered is 800 meters, which is 0.8 kilometers. And what is speed? Speed should be the relative speed, and relative speed when two persons are running in the same direction is the difference of their speeds. So 56 minus 48 kilometers per hour. You understand? Distance to be covered by the policeman is 800 meters. The relative speed between the policeman and the thief is 8 kilometers per hour. 56 minus 48 is 8 kilometers per hour. Yes or no? So basically the policeman is running 8 kilometers per hour faster than the thief. So at this rate of fastness, how much time will it take to cover 0.8 kilometers? What happens? Only look at the magnitudes. I mean, units are anyway comparable, right? So 0.8 by 56 minus 48 is 8. 0.8 by 8 is 0.1. 0.1 hours. 0.1 hour is equal to what? 6 minutes. So quantity 1 is 6 minutes. Quantity 1 is 6 minutes. Now look at quantity 2. What is quantity 2? Time a man will take to finish a marathon of 21 kilometers. This man has to finish a marathon of 21 kilometers. Right? Man has to finish a marathon of 21 kilometers. If a man runs with a speed of 30 kilometers per hour in the first 15 minutes, his speed is going to be 30 kilometers per hour. And then decreases his speed by 3 kilometers per hour after every 15 minutes. So initially he will start with 30 kilometers per hour, and later on every 15 minutes his speed will reduce by 3 kilometers per hour. Here itself you should know that quantity 2 is going to be way more than quantity 1. Without putting pen on paper, you should know that quantity 2 is going to be greater than quantity 1. How can I say that? See, what was his initial speed? 30 kilometers per hour. At 30 kilometers per hour, if he runs for, let's say, 15 minutes, how much distance will he cover? In the first 15 minutes, how much will he cover? See, his speed is 30 kilometers per hour in the first 15 minutes. First 15 minutes is nothing but 1/4 of an hour, right? Which is equal to 1/4 of an hour. So in 1 hour, if he can run 30 kilometers, in 1/4 of an hour, he will cover how much? 30 by 4, which is 7.5 kilometers. In how many minutes? In 15 minutes. Now the point to be noted, guys, is in the first 15 minutes, he has covered only 7.5 kilometers. Which means obviously to cover 21 kilometers of marathon, he will need much more than 15 minutes. Which means definitely quantity 2 is going to be more than 15. And 15 itself is more than 6. Remember, quantity 1 is just 6 minutes. In quantity 2, with just half of the calculation, not even half of the calculation, we have found that quantity 2 is going to be more than 15. You understand? Quantity 2 is going to be greater than 15. If quantity is greater than 15, obviously quantity is greater than quantity 1, because quantity 1 is just 6. So if you're trying to solve the complete question, that how much time will it take to cover, how much distance will he cover in next 15 minutes, then how much will he cover in the third 15 minutes, and then fourth 15 minutes, that's how you'll have to solve it, right? Suppose only quantity 2 is given as a question, where we have to find out how much time will this man take. We'll have to work in 15-minute slots. In the first 15 minutes, he has covered 7.5 kilometers. How much will he cover in the next 15 minutes? Because his speed in the next 15 minutes will be reduced by 3. Initial speed is 30 kilometers per hour. In the next 15 minutes, his speed will be 27 kilometers per hour. 30 minus 3. And then 24 kilometers per hour. And then 21 kilometers per hour, and so on. So the point is, no need to do the full calculation. After just the first step of quantity 2, you get to know that quantity is more than 15 minutes. And because it is more than 50 minutes, Q2 is more than Q1. So quantity 2 should be more than quantity 1, which is option B here. Or quantity 1 is less than quantity 2. Quantity 1 is less than quantity 2. I hope all of you have got the answer, right? All of you have understood this, right? Simple answer is B, option B, 1 less than 2. Don't waste your time in doing the full calculation. It's just a comparison. So wherever you can come to a definite comparison, just stop there and mark the answer. All right, should we go for the next one now? Quantity 1 is less than quantity 2. Right? Yeah, let's move to the next question now. Let's just go to the next question now. Yeah. Okay, here's the next one on your screens now. Now this time it is again a similar question, but time and work is involved. What he says, quantity 1. He says quantity 1 is the number of days one man and one woman will take to finish a job. If 3 men and 2 women can do the task in n days, while 6 men and 8 women will finish it in 0.4 n days. So basically absolute numbers have not been given. We have been given values in terms of n, right? N and 0.4 n. And then quantity 2, he says, what will be the value of t by 39? So quantity 2 is nothing but t by 39. If a man finished 1/4 of his work in 10 days and reduced his speed to its quarter to finish the remaining work, such that the total number of days he will take to finish the work is t. Quick. Should not take more than 1.5 minutes in my view. See if you are able to crack it. Got it? You have to find out quantity 1 and quantity 2, both of which in my view will come in terms of n, and then you have to compare the two values, two quantities. Okay, answers have come in. Let's see if you have got the right answer. So let's take it up. All right, let's take this up. Here we go. And now he's talking about two quantities again, both of which are in terms of, some questions which are in the form of time and work. So quantity 1, number of days one man and one woman will take to finish a job. So basically, how much time will one man and one woman take to finish a job if 3 men and 2 women can do a task in n days, while 6 men and 8 women will finish it in 0.4 n days. So we are talking about quantity 1. Let's do the calculation. 3 men and 2 women can do it in n days, which means what? 3m plus 2w. 3m plus 2w is equal to 1 by n. Remember, if the work can be done in n days, the capacity is 1 by n. So the total capacity of 3 men and 2 women together is 1 by n. Right? They can do the task in n days, which means their capacity is 1 by n. 3 men and 2 women together. Similarly, if you look at next equation, it says 6 men and 8 women will finish it in 0.4 n days. They will take 0.4 n days, which means 6 men plus 8 women. Their total capacity is 1 by 0.4 n. The number of days required is 0.4 n, which means the capacity is 1 by 0.4 n. And this, upon further simplification, will give you 5 by 2 n. 0.4 equals to 2 by 5, right? So it gives you 5 by 2 n. So these are the two equations we have. We know 3m plus 2w equals to 1 by n. We know 6m plus 8w equals to 5 by 2n. Two equations and two variables. Can you not solve? You can solve. You can find out what is m and what is w. Once you get m and w, you have to find out what is m plus w in terms of capacity. And that capacity will give you the number of days. Unitary method. Very easy to solve, right? Unitary method. So solve for m and w. Basically, you have to solve for m and w. Now, what's the easiest way of solving for m and w here? I think what I can do is, let's multiply the first equation. Let's multiply this equation with 2. Let me multiply by 2. Because 3m into 2 will give you 6m. So I can find out the value of w easily. So what do we get? 3m into 2, 6m. 2w into 2, 4w equals to 2 by n. And what's this equation? Straight. This equation straight is 6m plus 8w equals to 5 by 2n. Now simplify. 6m and 6m get cancelled. 8w minus 4w is 4w equals to okay, I can do one thing. Instead of taking 2 by n, I can take it as, this 2 by n can be taken as 4 by 2n. 2 by n can be taken as 4 by 2n. So 5 by 2n minus 4 by 2n is 1 by 2n. 5 by 2n minus 4 by 2n, right? 6m minus 6m, 0. 8w minus 4w, 4w. 5 by 2n minus 4 by 2n is 1 by 2n. So 4w equals to 1 by 2n. 4w equals to 1 by 2n, which implies w equals to 1 by 8n. W equals to 1 by 8n. Just remember this, keep this in mind. Now, substitute w in this equation. Whatever w you have got, substitute in this equation to get m. Yes or no? So what happens? What do we get? Say 6m plus 8w. So 8 into w is 1 by 8n equals to 5 by 2n. So 8 and 8 gets cancelled. We get 6m equals to 5 by 2n minus 1 by n. 5 by 2n minus 1 by n can be taken as 2 by 2n. 1 by n goes to the other side, becomes minus 1 by n. It can be taken as minus 2 by 2n. So 5 by 2n minus 2 by 2n is 3 by 2n. Again, upon further simplification, we'll get m equals to, this goes 2 times. I mean, all about cancellations and simplifying. M comes out to be 1 by 4n. M comes out to be 1 by 4n. So basically, you have to solve for m and w. See, you can cut down a few steps. Like for example, whatever I've written here is actually a copy of this. You can cut down a lot of steps and save your time here. Anyway, the solution is not over yet. Have we found quantity 1? No. Quantity 1 is nothing but number of days one man and one woman will take. So a woman's capacity is 1 by 8n, man's capacity is 1 by 4n. So what is the total capacity? What will be the total capacity? 1 by 4n if one man and one woman work together. M plus w is 1 by 4n plus 1 by 8n. This comes out to be 3 by 8n. See, their capacity is 3 by 8n, implies number of days will be 8n by 3. Number of days is going to be 8n by 3. So quantity 1 is 8n by 3. Right? Quantity 1 is 8n by 3. Or you can, there are other ways of solving it. You need not do this always. You're getting it. I'm just using equations. You can also find out the ratio between the two. Like that total work can be taken as number of men into number of days. That concept also can be taken. If you're not comfortable doing this, see, this looks to be lengthy but very quick to solve. I mean, cut down the amount of time being taken for explanation, right? Just look at the time that you'll need to solve. The other way to do it is, the other way to find out quantity 1, if you don't want to do this, is, work. That total work is nothing but number of persons into number of days, right? So we can say 3 men plus 2 women together will finish it in how many days? N days. The same work can be done by 6 men plus 8 women in how many days? 0.4 N days. So based on this, you'll get the ratio of men and women. Right? Once you get the ratio of men and women, again you'll have to substitute in these equations to find out 1M, 1W, and then find out the total work. Either ways, it will need a little bit of time. You're getting it? Even if you find out the ratio, here, you will not get the answer there itself. You'll have to find out how much time will one man take, how much time will one woman take, and then substitute it back. Right? I mean, that also would take a little bit of time. So that's about quantity 1. What is the quantity 1 we got? 8n by 3, right? Remember, quantity 1 is 8n by 3. Now let's work on quantity 2. Quantity 1 is 8n by 3. Now quantity 2. Work on quantity 2. What does it say? We have to find out the value of t by 39. So quantity 2 is actually equals to t by 39. Quantity 2 is t by 39. Now, a man finished 1/4 of his work in 10 days. He has finished 1/4 of the work in how many days? 10 days. And reduced his speed to its quarter to finish the remaining work. See, what is the remaining work? 3/4 is the remaining work. He's finished 1/4 in 10 days, 3/4 is the remaining work. Now actually, if 1/4 has taken 10 days, 3/4 should take 30 days. If 1/4 has taken 10 days, 3/4 should take 30 days. But remember, the remaining work was done at a reduced speed. And he reduced his speed to what? To its quarter. Reduced his speed to its quarter means what? He's working at 1/4 of his speed. If he's working at 1/4 of the speed, the time taken will be 4 times. So which means he'll take 120 days to finish the remaining work. You getting it? Straight. First he finished 1/4 in 10 days. 10 N days, sorry. 10 N days. 10 N days, right? He's finished 1/4 in 10 N days. So to finish 3/4, he will take 30 N days, 3 times. However, he finished the remaining work at a reduced speed. And he reduced his speed to its quarter, which means he made its speed 1/4. You know that if speed is 1/4, time taken will be 4 times. If speed is 1/4, time taken will be 4 times. So instead of 30 N days, he'll take 4 times of 30 N days, which is 120 N days. You're getting it? So 10 N days for the 1/4 of the work and 120 N days for 3/4 of the work. Such that the total number of days he will take to finish is T. Total number of days he will take to finish is T. So basically he's saying that T is equal to total number of days T. Total number of days T is equal to 10N plus 120N, which is equal to 130N. You don't have to write this step, in fact. You can directly write 10 plus 120, 130N. T is equal to 130N. But what is he asking us to find out? Quantity 2 is T by 39. T by 39. So can it put T equals to 130N now? Yes. It is 130N by 39. So this is like 3 times and 10 times. 10 by 3N. So which implies quantity 2 is equal to 10N by 3. 10N by 3. What was quantity 1? Remember, earlier we have found quantity 1. 8N by 3. What is quantity 2? 10N by 3. Which is more? Quantity 2 is more. Very clearly, Q2 is more than Q1. Q2 is more than Q1. Q2 is 10 by 3. Q1 is 8 by 3. Whatever be the value of N, Q2 will always be more than Q1. So Q2 is more than Q1. Option D. Option D. Q2 is more than Q1. Quantity 2 is more than quantity 1. Quantity 2 is more than quantity 1, right? That's your answer. Okay, so definitely quantity 2's calculation is a lot easier than quantity 1 calculation, right? But quantity 1, again, there are 2-3 different approaches of finding out the number of days required by one man and one woman. Whatever method you have been following, like some people do this concept of LCM, right? They use this technique of LCM to solve such questions. So you can use that as well. You can go by unitary method that we have discussed, or maybe you consider work as number of persons into number of days, get the ratio between men and women. And after you have got the ratio between men and women, what we actually do is we try to convert the whole question only in terms of men and only in terms of women separately. That will give us the capacities of man and one woman, one man and one woman. And then add those two capacities to get the total capacity, reciprocate to get the total number of days. See, explanation will always sound lengthy. It will take time. But if I am taking 5 minutes to solve a question here, does not mean that it will actually take 5 minutes for you to solve it. I am explaining it, I am not solving it. Yeah, so just consider that factor when you are when you are looking at the solution, right? Don't panic immediately saying that it can't be solved in the exam, or is there a shortcut or not. There need not be a shortcut for every question. And believe me, the type of questions which are being asked these days in bank exams, bank or SSC exams, especially bank exams, SBI, PO, IBPS, PO, is that they have made it really time consuming. Earlier, where days when they used to ask one question where a shortcut formula can be applied and then you can get the answer. But sometimes what happens is but these days what is happening is they are using 2-3 different concepts within the same question for that answer to be arrived at, right? And that would definitely take longer than the regular method. If you still feel it's lengthy, I think the only way to solve it is just skip and go to the next one, right? Okay, let's go to the next question now. So what we will do next is take up something on missing data interpretation. Now you know that missing data interpretation has been a popular question type in the recent exams, right? So let's discuss something on missing DI. I will present I'll present the data to you all first. Try to read, understand the data first, and then we will look at the questions, right? This is a missing data interpretation question which involves probability, right? So let's see if you're able to solve these questions. Here we go. So here's the question, the next set of data that we have. See what it says. Study the following information carefully. Study the following information carefully and answer the given question. So this is, one question which has got, set of 5 questions actually on data interpretation. So the line graph shows number of 3 colored balls in 4 different boxes. The table shows the probability of different cases. Some data is missing. So basically it's talking about a line graph which shows the number of balls in different boxes. What are the different boxes? Box A, box B, box C, box D. 10, X, 7, and the blue line indicates the number of blue balls, red line indicates the number of red balls, and the green line indicates the number of pink balls. Of course, some of the values have not been given, like X here, X minus 3 here, Z here, and so on. Look at what is given in the table. The table talks about probability, 3 different cases, I guess, right? 2 balls are drawn, both are red balls. 3 balls are drawn, 2 are blue and 1 is red. And here 2 balls are drawn, either the 2 are red or the 2 are pink. And the probabilities have been given. Some of the values are missing. As you can see, box A, third case, the value is missing. Box B, second case, the value is missing. In box C, both first and second cases values are missing. Yeah. So that's the data we have. Now there are some important points given here, right? Look at those points. All balls mentioned in each case have been drawn simultaneously. All the balls mentioned in each case have been drawn simultaneously. So when he's talking about 2 balls being drawn or 3 balls being drawn, he says all of them have been drawn simultaneously, not one after the other. And then second point which he has mentioned here, which is very important in my view, is that consider the numerator of the probabilities given to be equal to the favorable number of ways and the denominator to the total outcomes, right? And the denominator should be compared to the total outcomes. Okay. So keeping these points in mind, the line graph, the table which talks about various probabilities, and the 2 points in the note given here, you got to answer the questions, right? Try this out now. So try and study the data first. It's very important for you to understand what is given in the data and also understand what all can be extracted from the given data before you proceed to solve the questions. Yeah. So try and understand the data first and then we will look at the questions. Like I said, there are 5 questions here. See, 1, 2, 3, 4, 5 questions are there. We'll look at these questions one after the other. But before that, let's study the data first. Okay. So let me explain you what is given here. Simple points to be noted. Number 1, the line graph talks about the number of balls. So the blue line indicates the number of blue balls, the red line indicates the number of red balls, and the green line indicates the number of pink balls, right? And there are 4 different boxes, A, B, C, and D. So how many blue balls are there in box A? X. That value is not known to us. How many red balls? 10. How many pink balls? 7. And similarly for the other boxes, like here there's unknown value Y, here there's unknown value X minus 3, here there's an unknown value Z. We'll figure out, I mean, that it's not really missing. Some way or the other, these values can be found, right? So the line graph talks about simple data, number of balls of these 3 different colors, blue, red, and pink, in these 4 boxes. What is given in the table is very important. He's talking about various probabilities, right? What is case 1? Case 1 is about 2 balls which are being drawn and both are red balls. So the probability that this would happen in box A is 45 by 300. Probability that this could occur in box B is 15 by 325. For box C and box D, it's not given to us. So that data is missing. What is case 2? He says 3 balls are drawn, out of which 2 are blue and 1 is red. Probabilities have been given for some of the boxes. Case 3, 2 balls are drawn, either both are red or both are pink. Either the 2 are red or the 2 are pink. These are the 3 cases. The most important points are again given here in the note, right? First point says all the balls mentioned in each case have been drawn simultaneously. So you're all pulling these 2 balls together, or these 3 balls together, or these 2 balls together. It's not one after the other, right? The second point to be noted is, consider the numerator of the probabilities given to be equal to the favorable number of ways, and the denominator will be the total outcomes. See, what is the definition of probability? What is the definition of probability? What is probability? Probability is nothing but the total number of favorable ways, the total number of favorable outcomes, right? Number of favorable outcomes by total number of outcomes. Yes or no? Probability is nothing but number of ways in which you can get the desired output divided by the total number of ways. So what he says is, in all these numerators and denominators that you see here, the numerator represents the number of favorable outcomes and the denominator represents the number of favorable outcomes. See, observe, 45 by 300 can be further simplified. I can say 45 by 300 is 9 by 60, or I can say it is 3 by 20. 15 into 3, 15 into 20. I can write it is 15 by 20, 3 by 20. Yes or no? 45 by 300 is as good as 3 by 20. But he did not simplify it to 3 by 20. Why? That also is correct. Strictly speaking, probability is 3 by 20 only. This can be further simplified. But why has he given in terms of 45 by 300 and not 3 by 20? Because here when you say 45 represents the number of ways in which both the balls can be read in box A. See, what is the case we are talking about? Both red balls. So if you want to draw 2 red balls from box A, the number of ways in which it can be done is 45. The total number of ways of selecting 2 balls from box A is 300. Now, based on this data, can you not find out what is the value of X? You can find it out. Similarly, if you want to draw 2 red balls from box B, that can be done in 15 ways. If you want to draw 2 balls from box B overall, it can be done in 325 ways. Number of favorable outcomes, both are red balls. Total number of outcomes, 2 balls are being drawn. You understand? Likewise, when I want to draw 3 balls from box A, the total number of ways of doing it is 2300 ways. But if I want to draw 3 balls in such a way that 2 are blue and 1 is red, it can be done in 280 ways. So based on this data, I will be able to find out all these missing values, X, Y, X minus 3, Z, and so on. Right? Let's take one of the examples. One example before we move to the questions. For example, let's say I want to find out what is the value of X. What is the value of X? According to the data line graph, box A has got how many red balls? 10 red balls, right? Box A has got 10 red balls. It has got X blue balls. It has got 7 pink balls. Yes or no? 10 red, X blue, and 7 pink balls, right? Now look at this value here. What is this? He says the probability that when you draw 2 balls from box A, both are red, is 45 by 300. Probability of 2 red balls in box A is 45 by 300. What is this 45 by 300 representing here? The number of ways in which I'm just overwriting here number of ways in which you select 2 red balls. 2 red balls. So 45 is the number of ways in which you can select 2 red balls. What is 300? Number of ways, total number of ways of selecting 2 balls from, in which 2 balls can be selected from box A are selected. You understand? What is the probability case? 2 red balls. You are drawing 2 balls, both have to be red. So number of ways in which you can choose 2 red balls is 45. Number of ways in which you can choose 2 balls. Number of ways of choosing 2 red balls is 45. Number of ways of choosing 2 balls of any color is 300 in box A. We are talking about box A. So based on this data, can you not find out the value of X? Yes, you can find it out. Let me explain that to you, right? Let me just clear this up. I need space to do the writing part, right? Let me just clear the whole screen. Sorry. So what do? We have understood for box A, probability that both are red in box A is 45 by 300. This 45 by 300 is 6. See how many red balls are there in box A? 10 red balls. In how many ways can you choose 2 red balls out of 10? 10C2 ways. And remember, actually 10C2 is equal to 45. What is 10C2? 10 into 9 by 2 into 1. 10C2. 10 into 9 by 2 into 1. That's 90 by 2, 45. That's what has been given here, right? Now, how will you get the denominator 300? Denominator represents the total number of outcomes. See, very clearly says denominator is nothing but the total number of outcomes, total outcomes. What will be the total number of outcomes? The number of ways in which 2 balls can be selected in box A. The number of ways in which 2 balls can be selected in box A. Now, what is the total number of balls in box A? 10 plus 7, 17, 17 plus X. 10 plus 7, 17, 17 plus X. 17X, 17 plus X. 17 plus X. So the number of ways in which 2 balls can be selected is 17 plus X C2. 17 plus X C2. Which means when you simplify 17 plus X C2 equals to 300, you will get the value of X. Yes or no? Basically, it means 17 plus X C2. So now the conclusion is, it implies, so this is 45 compared already. 17 plus X C2 is equal to 300. Now, how do you simplify 17 plus X C2? 17 plus X C2 is as follows. We will not do the full simplification, but how do you simplify it? 17 plus X into 17 plus X minus 1 divided by 2 into 1. 17 plus X into 17 plus X minus 1 divided by 2 into 1 is equal to 300. Like NC2, right? What is NC2? N into N minus 1. 17 plus X C2, 17 plus X into 17 plus X minus 1 divided by 2 into 1. This is equal to 300. It will give you a quadratic equation. It will give you a quadratic equation. You have to solve for X from that. Right? You have to solve for X from that. And then you get whatever value of X. Right? Then you can find out the value of X minus 3 directly. Then you can find out the value of Y. Then you can find out the value of Z. There is no shortcut. If you think there is a shortcut, a better way of getting the answer, no. You have to deal with this. Maybe you can try the second case. Here, what is 280? 280 represents the number of ways in which 2 blue and 1 red balls can be selected. The number of ways in which, so maybe this will give you the answer faster. Just check that. If you think this is going to be lengthy, choose the second case. He says the number of ways in which 2 blue and 1 red ball can be selected from box A is 280. That also can be used. You don't have to follow the same, the first step always, right? If second probability is looking to be better way of simplifying it, go for second probability. The number of ways in which 2 blue and 1 red ball can be selected from box A is 280. Now 2 blue balls, total how many blue balls? X blue balls. So in how many ways can you select 2 out of X balls? XC2 ways. Into XC2 into 1 red ball. Total how many red balls? 10 red balls into 10C1 is equal to 280. Yes or no? I have to choose 2 blue balls and 1 red ball. 2 blue balls can be chosen in XC2 ways. 1 red ball can be chosen in 10C1 ways because there are total 10 red balls. This is equal to 280. Now solving this will be giving you the value of X faster when compared to the previous one. So you have to decide which one can give you the answer faster, which one can give you the missing value faster. Solve for X now. This will be easy. See what is 10C1? 10C1 is 10. 10C1, NC1 is equal to N, right? So 10C1 will be equal to 10. This 10 will cancel out with 0 here. So XC2 equals to 28, which means X into X minus 1 by 2 equals to 28. Or X into X minus 1 equals to 56. The sum of, see these two are consecutive numbers, right? X and X minus 1 are consecutive numbers. The sum of which two consecutive numbers is 56? 8 and 7. I can say 8 into 7 is 56. which means x is 8, x minus 1 is 7 obviously. So x is equal to 8. Concluded, x is equal to 8. So number of blue balls in box A is 8. By the way, I think we don't even have to, okay, I think we have missed on a very important point. We simply have y-axis here, right? From the y-axis also we can choose it. I don't know if these are meant to be given here or not. I'm not sure about this. Sorry, I think I missed on this part. But yeah, x directly points at 8. Then y can be taken as 11 in that case. Yeah, it comes between 10 and 12. This is x minus 3, right? It should be 5. Yeah, but I'm not sure if the real question had these values or not. Z, what is z? It comes between 8 and 10. So z can be taken as 9. Then we don't have to do all this drama in the exam, right? Then it becomes a lot simpler. Okay, so let's proceed. Anyway, the values are known to us. Even if so the idea is, even if this y-axis is not given to us, let's say, which I think was not the original case. Even if this y-axis is not given, this is how we can find out. Right? Using the y-axis, we can find out. I realized that only when I got x equals to 8 and I found that it is matching with this y-axis. Sorry. So y will be equal to what? It is between 10 and 11, 12, right? So it should be equal to 11. It should be equal to 11. You can just check that and confirm. Yeah. Now let's move to the questions. So here's the first question for you all. Yeah, I think you can just compare with y-axis in the given format to get the values. Now answer the questions. Answer the questions now. So the first question here says, if two balls are drawn from box D, then what is the probability that either both are red or both are pink? If two balls are drawn from box D, what is the probability that either both are red or both are pinks? We are talking about box D. Then why do we need this data? I don't think this data is needed at all, right? If y-axis is given, we will not need this data at all. Just look at that. Two balls are drawn from box D. See, box D has got 6 blue balls. 6 blue balls. The Z can be taken as what? It is between what, 8 and 10, right? So it can be taken as 9, right? So I think 9 red balls, 6 blue balls, 9 red balls, and 15 pink balls. 15 pink balls. This is about box D. So he says two balls are drawn from box B. What is the probability that either both are red or both are pink? He's asking us to find out this value. Both are red or both are pink. Yeah. So both are red or both are pink. See, both should be red or both should be pink. In how many ways can you choose 2 red balls? 9C 2 ways. Total 9 red balls. You have to choose 2, 9C 2 ways. Or remember, in permutations and combinations and probability, or would mean plus. So let's take plus. In how many ways can you choose 2 pink balls? Total 15 pink balls. You have to choose 2. It can be done in 15C2 ways. So this is the number of favorable outcomes, right? Probability is nothing but the number of favorable outcomes by total number of outcomes. So number of ways in which 2 red balls can be chosen, 9C2. Number of ways in which 2 pink balls can be chosen, 15C2. Divided by total number of ways. What is the total number of ways? See, total number of balls in box D is how much? 15 plus 9, 24 plus 6, 30. 30. Yes or no? 6 and 9, 15 plus 15, 30. So out of 30 balls, we need to choose 2. It can be done in 32 ways. Simplify this and we'll get the answer. Yes or no? 2 red, 2 pink, 2 different cases. Or means plus, right? Either or. So either both are red, 9C2, or both are pink, 15C2. Divided by total number of outcomes is 30C2. Simplify this. What is 9C2? 9 into 8 by 2, or basically 9 into 4, 36. What is 15C2? 15 into 14 by 2. So 15 into 7, it is 105. Divided by 30C2, it is 30 into 29 by 2, which is nothing but 15 into 29. 15 into 29 is 290 plus 145. 290 plus 145 is 435. Yeah. So 36 plus 105, it is 141. 141 by 435. 141 by 435. Simplify it further. 141 by 435. I think both are multiples of 3, right? This is 3 into 47. 3 into 47. This is 3 into 145. So 47 by 145 should be the answer. 47 by 145. Yeah, option B should be the answer. 47 into 3 is 141. And 145 into 3 is 435. 47 by 135. But I would still assume that these values are not given, because see, the point is, if the values are known directly to us, there is no significance of this table at all. Of course, you can say that it has been given to confuse us, like I got confused in the first trial, right? I thought we have to use the table. I mean, the fact that table was given, I thought we have to use the tables to find out the values of x, y, z here. But directly x, y, z can be obtained from the y-axis. Anyways, you know how to use it from y-axis. You also know how to use it using the table. I mean, how to get the values using the table. Let me show the next question. Here's the next one. He says 60% of the blue balls are taken from box C and put into box A. Then by what percent has the number of total balls increased in box A? Try to solve this now. Try to solve this quickly. Yeah, I think we got to understand that there has been an error in the presentation of these questions. These values are not known to us. I would just strike it off, and we will have to solve it using the lengthy process. That's why I was wondering how come there's a change here. These values are not given to us. Forget about these values. So in the previous question also, for you to find out the answer, you cannot directly take the value of x. You have to, I mean, x or whatever we had done, right? We took directly the number of red balls as 9, right? You cannot do this because these are not given. I'm sorry about this error here. These values on the y-axis have not been given to us. So I think we got to solve this question once again, right? Because it's not as simple as it looks to be, right? Let me clear the whole screen and solve this question again for you. At least to the point where we get the value of z. After that, it is the same solution, right? So note down that these values are not known. Sorry for this error caused, yeah? Table is required. Definitely the table is required. This y-axis is not given to us. Now go back to this previous question. 2 balls are drawn from box D. What is the probability that either both are red or both are pink? Now in box D, we know that there are 6 blue balls and there are 15 pink balls. But how many red balls are there is not known to us. So that has to be found. How can you find that? How can you find it? Use the table. Use any one of the cases. I think with respect to box D, only the second probability is given, right? 135 by 4016. So we have to use that. Now according to this probability given here, it says the number of ways in which 2 blue balls and 1 red ball can be chosen is 135. In box D, the number of ways in which 2 blue balls and 1 red ball can be chosen is equal to 135. Which means what? See, how many blue balls do we have? 6 blue balls. In how many ways can you choose 2 blue balls out of 6 blue balls? 62 ways. Into 1 red ball. See, there are how many red balls? Z number of red balls, right? Z. These are pink balls. These are red balls, right? In how many ways can you choose 1 red ball out of Z red balls? Z ways basically. ZC1, which is equal to Z. This is equal to 135. So solve for Z first. So what happens? 62. 6 into 5 by 2. So 30 by 2, 15. This is equal to 15. Right? 62 is 15 and 15 goes 9 times. So now I can say that ZC1 is equal to 9. And you know that ZC1 is equal to Z. So Z is equal to 9. So now I can say that there are 9 red balls. Not with respect to the y-axis. You have to find out the number of red balls. 9 red balls. Now that you've got 9 red balls, solve the question. 2 balls are drawn. Both are red or both are pink. So like the previous solution, right? I mean, now the solution remains the same. Both are red. So 9C 2 ways. Or plus both are pink, 15C 2 ways. Divided by total how many balls? 15 plus 9 plus 6, 30C2. Simplify this, you'll get option B as the answer. Right? Option B is the answer. So table is required. This table is required. Okay. Now let's solve the next question. In the next question again, you don't know what the y-axis is, right? Based on the table, find out the missing value and then answer the question. So he says 60% of the blue balls are taken from box C and put into box A. Then by what percent has the number of total balls increased in box A? So 60% of the blue balls from box C are put into box A. So by what percentage has the number of balls increased in box A is the question. I'll leave you with this for 1 minute. Your clock starts now. 12. 12 is what some of you have marked, waiting for more responses. I think most of you have got 12 as answers. Some of you have also marked 10. 10% option A. Should we take it up? All right, let's take it up. Time is up. Let's see what the solution is. So he says 60% of blue balls are taken from box C and put into box A. So here the discussion is about box C and box A. So 60% of the blue balls from box C are put into box A. Then by what percent has the number of total balls increased in box A? Now see, for us to be able to answer this question, first of all, we need to know the number of blue balls in box C. How many blue balls are there in box C? It's an unknown value. It is x minus 3. We know the number of pink balls are 8, number of red balls are 12, but number of blue balls is not known to us. So first of all, we got to know the value of x. And then put into the box A. In box A also, we have to know what is the total number of balls. We know the number of red balls, number of pink balls, but we do not know the number of blue balls. So unless we know what is the number of blue balls here, we cannot find out the total. And unless the total is known to us, we cannot answer the question. So I think we should work around finding out the value of x. That's the idea. Once you get x, this is x minus 3. Yes or no? You get x here, you'll get x minus 3 here. Okay. So let's find out x. Let's find out x, number of blue balls in box A. How can you get that? If you see with respect to box A, two probabilities are known to us. Right? Two of the probabilities are known to us. But the one which involves blue is only the second probability, right? First probability is about both red balls. It won't help. The number of ways in which two red balls can be chosen is 10C2. 10C2 is equal to 45. So that doesn't really help. What will help is the second case, second probability. The number of ways in which two blue balls and one red ball can be chosen is 280. Two blue balls and one red ball can be chosen is 280. I think we had already solved this, right? While we are finding out the value of x. So for A, probability that we can choose two blue and one red. Not the probability actually, the number of ways. It's not probability, we are only looking at the numerator, right? The number of ways in box A that we can choose two blue and one red ball is equal to 280. Now how many blue balls are there in box A? X blue balls. So XC2 into how many red balls? 10 red balls. 10C1 equals to 280. So when you simplify, 10C1 is 10, right? It gets cancelled here. XC2 equals to 28, which means x into x minus 1 is equal to 56. So we had discussed, right? Product of two consecutive numbers is 56, implies x is equal to 8. See, 8 into 7. 8 into 7 is 56. 8 sevens are 56, right? So x is equal to 8. So basically this is equal to 8. 8 here. And then this is x minus 3. So 5. Now we are done. Now we can answer the question easily. He says 60% of the blue balls are taken from box C. How many blue balls are there in box C? 5. So blue in box C is equal to 5. Implies 60% of 5. What is 60% of 5? 3. 60% of 5 is 3. So basically 3 balls are moved from box C to box A. Plus 3 here. 3 balls in box A. He's asking us to find out by what percent has the number of total balls increased in box A. By what percent has the number of total balls increased in box A? See, percentage increase. How can you calculate the percentage increase? Actual increase is 3 balls. How many balls have increased in box A? 3 balls. 3 balls from C have been put into A. So number of balls increase is 3. Divided by total number of balls. Total number of balls initially are how much? 10 plus 8 plus 7. 10 plus 8 plus 7, which is 25. So 3 by 25 into 100. And 3 by 25 into 100 is 12%. 4 times, so 3 4 is 12. So option C would be the answer. Right? Option C, 12 will be the answer. Remember, in the denominator you should take 25. You should not take 28. Initially there were 25 balls. So with respect to 25, how much is the increase? Not after adding 3 balls, don't make it 3 by 28. You're able to follow. When 3 balls are moved from box C to box A, the total number of balls in box A will become 25 plus 3, 28. But that does not mean that you will take 28 in the denominator. Denominator will remain 25 only, right? By what percent has the balls increased? So initially there were 25, now it has increased by 3. So 3 upon 25. That's the percentage we are looking at, right? So option C is the answer. Let's go for the next one. Here's the next question. Try to answer this now. If 3 balls are taken out from box B, then find the probability of at least 1 pink ball. So he's talking about 3 balls being taken out from box B. And out of these 3, at least 1 has to be a pink ball. I'll leave you with this for 1 minute. Your clock starts now. Got it? Waiting for answers. 3 balls are taken out from box B, then find the probability of at least 1 pink ball. A simple question, all you have to do is find out the number of pink balls in box B. Y is missing, right? So that Y needs to be worked on. Anybody who's got the answer? All right, I think I've given you guys enough time. Let's look at the solution now. Should we go ahead or you want me to give you more time? See, anyway, you cannot be spending so much time in the exam, right? So you have to be careful about it. I mean, you have to be quick. But we have got only one response so far. So I'm assuming if I have to give you some more time. Okay, let me do one thing. Last 45 seconds. It's supposed to be an easy one. I'm not sure why is it taking so much of time. Quick. Option B, option A, different answers have come in. Chalo, 15 more seconds. All right, time is up. Let's discuss the solution now. So he says 3 balls are taken out from box B. Then find the probability that at least one is a pink ball. Now, before we work on this probability, we got to first find out what is the value of Y. We know that box B has got 6 red balls, 9 blue balls, and Y pink balls. But what is that Y is to be known. How can you find that out? Based on the probabilities given here. Now see, since Y is related to pink, it is about pink, we cannot use probability 1 and probability 2. Because in probability 1 we are talking about red balls, in probability 2 we are talking about blue and red. Only probability 3 is the case where we get pink into picture. So let's work for probability 3. And you know, for box B, the probability that either both the balls are red or both the balls are pink is 70 by 325. And given, going by the note given in the directions, these are actual values. These are not simplified values, right? So 70 indicates what? 70 is the number of ways in which you can either select 2 balls or 2 red balls or 2 pink balls. So the number of ways in which 2 red balls or 2 pink balls can be chosen from box B is 70, right? Then how many ways can you choose 2 red balls? Total 6 red balls. It can be chosen in 62 ways. Or see, either both are red or both are pink. So either both are red balls, 62 ways. Or, which means plus, both are pink balls. How many pink balls do we have? Y pink balls. So both are pink balls, YC2. This is equal to 70. 6C2 plus YC2 equals to 70. 6 red balls, we have to choose 2, 62. Y pink balls, we have to choose 2, YC2. Plus in between because we are talking about or. Either or, right? So you have to take plus, which is equal to 70. Number of favorable outcomes is 70. Right? Don't work on probability, only work on the numerator there. Now simplify this. What is 62? 62 is 15, right? 6 into 5 by 2, 30 by 2, 15. 15 and 70 minus 15. So this is equal to 15. So basically YC2 is nothing but Y into Y minus 1 divided by 2. So no, Y into Y minus 1 divided by 2 is equal to Y into Y minus 1 divided by 2 equals to 70 minus 15. 70 minus 15 is what? 55. Or into 2 will make it 110. Now the product of 2 consecutive numbers, Y and Y minus 1 are consecutive numbers, right? The product of which 2 consecutive numbers will give you 110? See, either solve the quadratic equation, but you can directly also do it, right? 11 into 10 is 110. If this is 11, and then Y minus 1 will become 10. 11 into 10 is 110. So we can conclude that Y is equal to 11. There are 11 pink balls. This is equal to 11. Now go back to the question. What is the question about? Find the probability that when 3 balls are chosen, at least one is pink. Probability of at least one pink ball. Now remember, probability of at least one can always be taken as 1 minus probability of no pink ball. We have discussed this in detail in our probability videos, probability and permutations and combinations videos of your TalentSprint program, right? So instead of finding out at least, see, at least one pink would mean what? When you are choosing 3 balls, B1, B2 and B3, when you're choosing 3 balls, at least one pink means what? 1 can be pink, 2 can be of other colors, or 2 can be pink, the third one can be of other colors, or all the 3 can be pink. But instead of taking 3 different cases, we simply assume that probability of at least one pink is nothing, I mean, it's not an assumption, it is actually 1 minus probability of no pink ball. So from the total probability, which is equal to 1, if I subtract the probability that we don't choose pink ball at all, we will get the probability where we have at least one pink ball. Now take this 1 minus no pink ball. See, the box B here has got 6 red balls, 9 blue balls and 11 pink balls. You don't want any pink ball at all. So only from this 9 blue and 6 red you have to choose. Right? If you don't want any pink ball, you have to choose only from the blues and the reds. So 9 blue and 6 red, total how many? 15. 9 plus 6, 15. So from 15, how many balls should be chosen? 3 balls. 15C3. Divided by total. Total number of ways. These are favorable outcomes. Total number of outcomes. So total how many balls do we have? 9 plus 6, 15. 15 plus 11, 26. So out of 26 balls, I got to choose 3 balls. 26C3. So this is your final answer. 1 minus 15C3 divided by 26C3. 1 minus 15C3 by 26C3. Simplify and you will get the answer. You have understood? Probability of at least one pink ball is equal to 1 minus probability of no pink ball. So 1 minus no pink ball. So which means choose from only blue and red. 9 blue, 6 red, total 15. I have to choose 3 balls. So 15C3. Divide by total, there are 26 balls in this box B. Choose 3, 26C3. Simplify and you'll get the answer. Simplify this. So it's like this: 1 minus 15C3 by 26C3 can be taken as 15 into 14 into 13 divided by 26 into 25 into 24. You understand? The denominator, the 3 into 2 into 1, and here the denominator 3 into 2 into 1 will get cancelled anyway. So 15, 14, 13, 26, 25, 24. Yes or no? So 13 goes 2 times. This is 5 into 3, 5 into 5. This goes 7 times. This goes 8 times. So 7 by 40. 7 by 40, right? 5 into 8 is 40. So it is equal to 1 minus 7 by 5 into 8, 40. 1 minus 7 by 40 is 33 by 40. 1 minus 7 by 40 is 33 by 40, which is option A. So option A will be the final answer to this question. Right? Option A, 33 by 40. So the probability that we get at least one pink ball from box B is 33 upon 40. Now remember, because there are 2 ways of solving it, like I said. At least one pink can be done in 2 ways. Only one pink, or 2 pink, or 3 pink. That's one way of doing it. The other way of doing it is 1 minus no pink. And 1 minus no pink is definitely easier in my view. So while many of you have got the right answer, 33 upon 40, all you have to check is, did you do it using the conventional method, considering all the 3 different cases, or the smart method where at least one can be taken as 1 minus none. This works in both permutations and combinations as well as probability. Even in case of permutation and combinations, when you have to choose, let's say 3 balls, such that no 3 are, at least one is pink. What you can do is, from the total number of ways of choosing 3 balls, subtract the number of ways in which you choose no pink ball. It will give the number of ways in which you get at least one pink ball. Yeah? So that's how you solve this one. Should we go for the next question now? I think there's one more question along with this data here, or 2 more questions in fact. Let's solve those 2 questions and then we'll wind up. Should we go for the next one? I hope this is clear to all of you. If you can acknowledge that, I would like to take up the next one. Yeah? Followed? Okay, Sachin Singh has confirmed that he has understood this, and so has Mudit Singh. So let me present the next question to you all, and it is on your screens now. So same data and a different question. If there are 24 balls in box A, find the difference between the probability of drawing 2 balls from box A such that both are either red color or pink color, and the probability of drawing 3 balls from box C such that 2 of them are blue color and 1 is red color. Try this, interesting one. Try it out. Anyone who's got the answer? Okay, not a single response, which indicates that you're struggling to arrive at the answer. I'll wait for around 30-45 seconds and then take it up. He says there are 24 balls in box A. You have to find out the difference between the probabilities of drawing 2 balls from A such that either both are red or both are pink, and 3 balls from C such that 2 of them are blue and 1 is red. I think what we should do is the values that you have found earlier, you should copy it here. No point in, and by the way, let me also tell you that this y-axis is not known to us. This is an error. Sorry about that. So x is equal to 8. See, we don't have to do the calculation always, right? X is equal to 8. We have already done this calculation in one of the earlier questions. This is equal to 5. I think we have also got y somewhere, right? Y came out to be 11. Y is equal to 11. Only z is the thing that we may have to find. Or that also was calculated somewhere. It came out to be 9. So we know all the values already. Then why does it take so much of time? See, we've already found the values of x, y and z, right, in the first 3 questions. So don't try to solve it again, because the data is the same. It is the same table. So the values cannot change. X, y and z cannot change. X needs to be calculated again? No, I don't think we'll have to calculate any of the values again, right? You just don't have to, because see, even if you calculate it again, recalculate it, you are going to use the same table. So how will it change, right? So it's very important that in answering questions on data interpretation where some data is missing, if something has been found in the earlier questions, you have to make use of that. Okay, let me solve this now. So he said that 24 balls in box A. Clearly 24 balls in box A. How can box A have 24 balls? Because x was 8, right? Okay, so maybe this time we cannot go with our earlier calculation. 24 balls in box A. 10 and 7 is 17 plus 8 is 25. Then find the difference between the probability of drawing 2 balls from box A. Okay, so I think we'll have to, what we have to do in this case is we have to forget about the table, right? Because he's himself mentioned that there are 24 balls in box A. Yeah, so I'll anyway close this up. This is not to be seen. This, yeah. Okay, let's go by the question. This time I think he has changed it, right? So he says if there are 24 balls in box A. If there are 24 balls in box A, see, 10 and 7, 17 is already there. So x should be equal to 7. Number of blue balls should be 7. 10 plus 7, 17. 17 plus 7, 24. Then find the difference between the probability of drawing 2 balls from box A such that both are either of red color or pink color, in the probability of drawing 3 balls from box C such that 2 of them are of blue color and 1 is of red color. See, if this x is equal to 7, this x minus 3 will come out to be 4. This will be equal to 4. X minus 3 will be equal to 4. So there are 4 blue balls in box C. And that's what he's talking about, right? He's talking about box A and box C. Now, probability of drawing 2 balls from box A such that both are either red color or pink color. So probability that 2 red or 2 pink are drawn from A. From box A, you draw either 2 red balls or 2 pink balls. So what's the probability? See, how many red balls are there in box A? 10. So choose 2 balls out of that, 10C2. Plus, how many pink balls are there in box A? 7. 7C2. Divide by total, how many balls are there in box A? 24. 10 plus 7 plus 7. 24 is anyway given here. So 24C2. This is the value. This is one of the values. Simplify this. 10C2. 10C2 is 10 into 9, 90 by 245. 7C2 is 7 into 6, 42 by 2, 21. And 24C2. 24C2 is 24 into 23 by 2. 24 into 23 by 2. So which is 23 into 12. 23 into 12 will be 230 plus 46, 276. And 45 plus 21 is 66. So 66 by 276. Or it can be further simplified as 11 by 46 times. 11 by 46 times, right? 11 into 6 is 66. 46 into 6. 240 plus 36 is 276. So the value for box A, I mean the probability that we are looking for box A is 11 by 46. Now, the probability of drawing 3 balls from box C such that 2 of them are blue color and 1 is of red color. So probability of drawing 3 balls from box C such that 2 are blue, and remember it's and not or, and 1 is of red color. Simplify this. 2 blue and 1 red, and 1 red. How do you do this? See, total there are 4 blue balls in box C. So in how many ways can you choose 2 blue balls? 4C2 ways. Since it is and, you have to multiply. It is the same case, not 2 different cases. Into 1 red. How many red balls are there? 12 red balls into 12C1. Divided by total. Total how many balls are there? 12 plus 8, 20. 20 plus 4, 24. 12 plus 8 is 20. 20 plus 4, 24. 24C3. Remember, 3 balls have been drawn. With respect to box A, it was about 2 balls. Either both red or both pink. With respect to box C, it is about 3 balls. Right? It is about 3 balls. Either, it's about 3 balls where 2 are blue and 1 is red. Now simplify this. So 4C2, 4 3 is 12 by 2 is 6. 12C1 is 12. So 6 into 12 is 72 divided by 24C3. What will be 24C3? Simplify this now. 24C3. 24C3 is 24 into 23 into 22. This denominator will be 3 into 2 into 1, which goes in the numerator now. Right? You're able to follow? Simplify that. Simplify this now. You have understood. We need 2 blue balls and 1 red ball. So 2 blue in 4C2 ways, 1 red in 12C1 ways. So 12C1 is 12, 4C2 is 6. 4 into 3 by 2. 6 12 is 72. 24C3 is 24 into 23 into 22 divided by 3 into 2, which goes in the numerator. Now simplify this. This goes 3 times, right? And this is 11 times. So 3 into 3, 9. 9 divided by 23 into 11. 230 plus 23, 253. Right? 3 3 is 9. 9 by 253. Yeah. Now he's asking us to take the difference. Remember, the difference is what? One probability is 11 by 46. The other probability is 9 by 253. You have to take the difference of these two. So your final answer is going to be, I'll leave the calculation to you. The final answer is going to be 11 by 46 difference 9 by 253. 9 by 253. So basically I think 506 can be taken as LCM. Let me complete this. 506 can be taken as LCM, right? Because 46 into 11 is 506. 46 into 11, right? What is 46 into 11? 460 plus 46, 506. So 11 into 11, 121. Yeah. Minus 253 into 2 is 506. So 19 into 2, 18. So 121 minus 18. How much is 121 minus 18? 103. Divided by 506. That's your answer. 103 by 506, which is option D. Right? Remember again, the contradictory part here is, while he has mentioned number of balls in box A is 24, if you go by the probabilities, it may not come out to be 24, it will come out to be 25. Remember, earlier we had found X to be 8 based on these probabilities. So we'll have to ignore the table. We'll have to ignore this table when you're answering this question, because very clearly he specified in the question itself that there are 24 balls in box A. But actually, as per the table, there will be 25 balls in box A. So go by the data given in the question, right? Don't consider the table in this case, right? And the last question from this session today and from this data interpretation set is on your screens now. Try this. He says 2 balls are drawn at random from box C. Then what is the probability that both the balls are of red color? Then the probability of both balls being red color is approximately what percentage less or more than the probability of drawing 2 red balls from box B? Quick. Two balls are drawn from box C. The probability of both balls being red color is approximately what percentage less or more than the probability of drawing 2 red balls from box B? Now this time he has not given any specific value in the question, right? So what you can do is you can go by the calculations that we have done earlier, right? Because for you to find out the number of, the missing values here, x, y, and z, you'll have to refer to this table because nothing has been specified in the question. And as per the table, we have already found that x is equal to 8, y is equal to 11, this will be equal to 5 obviously, and z is equal to 9, I guess. So whichever is required of these you can use. All right, time is up. Let's solve this now. So, like I said, since no specific value has been given in the question, we'll have to refer to the data to find out the missing values, which we have already done in the earlier questions. Okay, so attempt the question directly. Now we have to find out the, there is a percentage requirement here. What it says, the probability of drawing 2 red balls. We are drawing 2 balls from box C. So the probability of drawing 2 red balls from box C is approximately what percentage less or more than the probability of drawing 2 red balls from box B. Now what is the total count of box B? 11 plus 9, 20 plus 6, 26. What's the total count of box C? 12 plus 8, 20 plus 5, 25. Now, what is the probability of drawing 2 red balls from box C? 2 red balls of box C from box C. What is the probability? There are total how many red balls? 6 red balls. So 6C2 divided by 26C2, which comes out to be 6 into 5 by 26 into 25. All right. And the probability of drawing 2 red balls from box B. Okay, probability of drawing 2 red balls from box B. How many? Okay, sorry. Box C has got only 25 balls. I'm sorry. This is for box B, let us say. And this is for box C. Sorry. You're able to follow. Box B has got 6 red balls and total 26 balls. So 6C2 by 26C2. How about box C? Box C has got how many red balls? 12 red balls. So 12C2 divided by total 25 balls. 25C2. So this comes out to be 12 into 11 upon 25 into 24. Simplify these two first and then we'll do the percentage calculation. Right? Then we'll do the percentage calculation. So this goes 5 times. This goes 3 by 13 times. So 3 by 13 to 5 is 65. That's one probability that we need. What's the other probability here? 12 goes 2 times, 11 by 50. right? We have got both the values. Now understand, look at the question properly. C, probability of both balls being red colors in C, is what percentage less or more than B? C is what percentage less or more than B, right? We are comparing with B. C is what percentage less or more than B? See, a very popular question type from percentages. X is what percentage less or more than Y? X minus Y by Y into 100. So here an answer should be C minus B by B into 100. Right? Your final answer will be C minus B by B into 100. C is what percentage less or more than B. You're comparing with respect to B. So B should go in the denominator. So C minus B by B into 100. C minus B by B into 100. What is C? 11 by 50. So 11 by 50 minus B. What is B? 3 by 65. Divided by B. What is B again? 3 by 65 into 100. Do this calculation. I think the LCM of 50 and 65 is 650, right? 650 can be taken as LCM. So if 650 is LCM here, you understand 650 is LCM. 50 goes how many times? 13 times. So 11 into 13 is 143 minus 65 goes 10 times. This is 30. This should be divided by 3 by 65. 3 by 65. Sorry, there's very little space here. Multiplied by 100. So this goes 10 times. 10 into 3 becomes 30. Denominator becomes 30. And 143 minus 30 is how much? 143 minus 30 is 113. 143 minus 30 is 113. Divided by 10 into 3, 30. Into 100. Into 100. So clearly the answer is at least 300%. See, we have got a positive answer. We have got a positive answer. Plus. Which means it is more. So less is anyway ruled out. It is more. It is some percentage more. How much percentage more? See, 113 by 30. It is more than 3 times. So more than 300%. Right? Clearly answer is option B or option E. And actually when you simplify, you find that it is approximately 377, 378%. Right? I mean, calculation is your lookout. Option B should be taken as the correct answer. 377% more. Remember, 377% more. Option B. He's anyway asked us to find out approximate value, right? So you can approximately take option B as the answer. Don't do a precise calculation. This will be approximately 37 times, right? 3 into 37. 3 into 37 is 111. 111. This is 113. So approximately 37. Right? Or 38. I mean 388 basically. Okay. So option B should be taken as the answer. Option B, 377% more. And with this, we come to the end of this question on data interpretation. So important points here. Data is missing and the question is based on probability. Both of which are the new trends in the bank exams, right? I mean, you're being asked questions on data interpretation which involves concepts of arithmetic aptitude, time and work, time and distance, probability, permutations and combinations, profit and loss, simple and compound interest. And this is not the first time that we have solved such a question, right? Even in our earlier sessions, we have looked at a variety of such questions there, right? So the point is, it's just that the questions have become time consuming because a lot of calculation needs to be done before you arrive at the final answer. I mean, for you to arrive at the final answer. Otherwise, the concepts are all the same, right? The difficulty level has not gone up. The time required to arrive at the answer has increased drastically. And there cannot be a shortcut for every question out there. I mean, either you follow this process or you just skip and go to the next one. But the one thing which definitely comes handy and very, very useful for arriving at quick answers here is your numerical skills. So if you had really worked well on your numerical skills, you would have, I mean, there are better chances of you getting a good score compared to others. Okay, so I think the key point or the key takeaway from the session today is questions have become lengthy, questions have become time consuming, and yes, you got to be good at numbers. So all I would suggest is the next 20 days that you have for your IBPS PO mains exam, spend at least 1.5 hours per day on just doing simple calculations, 2-digit multiplication, additions, divisions, subtractions, all that we have done so far, right? It's all about simple numbers. Okay, so keep practicing on numbers. I'm sure that will help you improve your score in the exam. And we'll meet again with your next session on I think reasoning ability as a part of this IBPS PO main exam refresher that we have brought for you guys. The next session will be on Thursday. So I think it is going to be on 9th of November, right? The calendar is available on our YouTube channel. It is also available on our platform, TalentSprint's learning platform. So you can subscribe to our YouTube channel and get notified about all these live sessions that we have for you, right? And yes, we'll meet again on Thursday. Until then, keep practicing and take very good care of yourselves. Bye.